The F-14 Tomcat is one of the most recognizable carrier fighters ever built, but its real importance is not nostalgia or cinema. It was a specialized answer to a hard naval problem: how to defend an aircraft carrier far from land, against fast bombers and anti-ship missiles, while still fighting like a true air superiority aircraft when the fight became close. The Tomcat was large, expensive, complex, and demanding, yet for decades it gave the United States Navy a long arm at sea. The Grumman F-14 Tomcat was a twin-engine, two-seat, variable sweep wing fighter designed for carrier operations. Its primary country of service was the United States, with Iran becoming the only export customer before the 1979 revolution. Built by Grumman Aerospace Corporation, the aircraft served as a fleet defense interceptor, air superiority fighter, tactical reconnaissance platform, and later a precision strike aircraft. It first flew on December 21, 1970, and entered operational Navy service in 1974. The Tomcat replaced the F-4 Phantom II in the Navy's frontline fighter role and carried a crew of two, a pilot in front and a radar intercept officer behind. That second crew member was not a luxury. The aircraft was built around long-range sensors, heavy missiles, carrier navigation, and complex intercept geometry. The Tomcat came from the Navy's VFX program after the troubled F-111B failed to meet carrier fighter expectations. The Navy still needed a fighter able to protect carrier battle groups at long range, but it also wanted an aircraft that could survive air combat lessons learned during Vietnam. Grumman proposed a design that combined a powerful radar, heavy missile load, high speed, and variable geometry wings. The first prototype flew in late 1970, and the aircraft moved quickly because the operational need was urgent. Early F-14A squadrons deployed in the mid-1970s, including aboard USS Enterprise, and the aircraft became the Navy's premier fighter for the final decades of the Cold War. Iran ordered F-14s before the revolution because it needed a long-range interceptor for a large airspace. After 1979, that fleet remained isolated from normal U.S. support, creating a separate and unusual operational history. The development story also explains why the Tomcat was never a small or simple fighter. It had to launch from a moving deck, climb with heavy missiles, patrol over water, and return safely to the carrier with enough control at low speed. It also had to work inside a layered defense system that included airborne early warning aircraft, ship radars, controllers, and fighter crews. Grumman's answer was not optimized for one clean number on a brochure. It was optimized for a chain of tasks: detect early, intercept far away, identify the threat, fire if ordered, and still have enough performance to fight or return to the ship. The F-14 was shaped by the carrier environment and the fleet defense mission. Its variable sweep wings could extend for takeoff, landing, and low-speed control, then sweep back for high-speed flight. That gave the aircraft a broad performance envelope, but it also added weight and maintenance complexity. The F-14A used two Pratt & Whitney TF-30 turbofan engines, while later F-14B and F-14D aircraft used more powerful General Electric F-110 engines that improved acceleration and handling. The aircraft could reach roughly Mach 2.3 at altitude, but raw speed was only part of the design. Its size allowed large fuel capacity, a heavy weapons load, a strong radar, and a two-person crew. The AWG-9 radar gave early Tomcats the ability to search at long range and manage multiple targets. The later F-14D added the APG-71 radar, improved avionics, better displays, and updated sensors. The aircraft also used the TARP's reconnaissance pod, and in the 1990s the Lantern targeting pod turned the Tomcat into an effective precision strike platform. The cockpit arrangement mattered as much as the engines. The pilot managed formation, carrier recovery, and close maneuvering, while the radar intercept officer handled sensors, communications, navigation support, and weapons employment. This division of labor was especially useful before modern digital displays and automation became common. The Tomcat's large nose gave room for a serious radar, and its glove vanes, wing sweep schedule, tail surfaces, and broad fuselage were all tied to high-speed stability and carrier handling. It was not a lightweight dogfighter in the narrow sense. It was a naval system built around endurance, sensor reach, and the ability to bring heavy weapons back to a carrier if they were not fired. The Tomcat's most famous weapon was the AIM-54 Phoenix, a long-range missile designed to engage threats before they reached the carrier group. Paired with the AWG-9 radar, the Phoenix gave the F-14 a fleet defense reach that no earlier Navy fighter could match. The aircraft also carried AIM-7 Sparrow medium-range missiles, AIM-9 Sidewinder short-range missiles, and an internal M61A 120mm cannon. In a typical Cold War role, the Tomcat could launch from a carrier, climb quickly, receive direction from controllers, and intercept incoming aircraft far from the ship. Over time, its mission expanded. TARPS-equipped Tomcats provided tactical reconnaissance after dedicated reconnaissance aircraft left service. With lantern, laser-guided bombs, and improved crew training, the aircraft became a credible strike fighter. This did not erase its origins as an interceptor, but it proved that the airframe had more flexibility than its original mission suggested. The Phoenix missile is often treated as the whole story, but the complete weapons system was broader. Sparrow and Sidewinder missiles gave the crew medium and short-range options, and the cannon remained important for close engagements or warning shots. The radar could support wide-area search, track wildescan work, and coordinated intercepts with controllers. Later strike missions required different skills: target identification, laser designation, bomb delivery, and communication with ground or maritime forces. The Tomcat's value came from being able to carry several of these mission sets across a single deployment cycle. The F-14's operational history includes both U.S. Navy and Iranian service. U.S. Tomcats saw early combat over the Gulf of Sidra, where Navy F-14s shot down Libyan fighters in 1981 and again in 1989. During the Iran-Iraq War, Iranian F-14s were used as long-range interceptors and as airborne radar assets, though exact claims from that conflict vary and should be treated carefully. In U.S. service, the Tomcat flew combat air patrol, escort, reconnaissance, and later strike missions. It operated during the 1991 Gulf War, enforcement of no-fly zones over Iraq, operations in the Balkans, Afghanistan, and the 2003 Iraq War. By the final years of its Navy career, the Tomcat was no longer just guarding the fleet against bombers. It was finding targets, guiding precision weapons, collecting imagery, and supporting forces on the ground. The U.S. Navy retired the type on September 22, 2006, replacing it with the F/-18E and F/-18F Super Hornet. That operational record also shows the difference between design intent and real service life. The Tomcat was conceived around a Soviet bomber and missile threat, but it spent much of its later career in regional crises, patrol boxes, reconnaissance tasking, and precision support missions. Carrier crews valued the aircraft's endurance and sensor reach, but every sortie depended on a large maintenance effort below deck. In Iran, lack of normal spare parts forced local adaptation and careful husbanding of airframes. In both contexts, the aircraft's reputation came from crews, maintainers, tactics, and logistics as much as from the machine itself. The Tomcat's main strength was reach. It could patrol far from the carrier, detect targets at long range, and carry weapons that matched the fleet defense mission. The two-seat cockpit helped divide workload during complex intercepts, night operations, reconnaissance, and strike missions. Its variable sweep wing gave it carrier approach control without giving up high-speed performance. The aircraft was also adaptable. A fighter designed around Cold War missile defense later became a reconnaissance aircraft and then a precision bomber. In the hands of experienced crews and maintainers, the F-14 offered a combination of sensor power, endurance, weapons flexibility, and presence that made it valuable long after its original threat model began to fade. The same features that made the F-14 powerful also made it difficult to sustain. The swing wing mechanism, large airframe, and older avionics demanded heavy maintenance. Early TF-30 engines could be unforgiving at high angles of attack, and engine handling problems affected the F-14A's reputation until later variants improved performance with F-110 engines. The aircraft was not stealthy, not cheap, and not simple. Its long-range Phoenix missile system was impressive, but it was also specialized and costly. As the Cold War ended, the Navy needed fewer dedicated fleet defense interceptors and more multi-role aircraft that were cheaper to operate across the carrier air wing. The Tomcat could adapt, but adaptation did not remove its operating burden. There were